So I'm suggesting that we get this started. This cafe is about color management, and because I'm far from an expert when it comes to that, we have invited an expert. That is Dietmar Fuchs from ColorLogic, and so the main topic was multi-channel. Or no, not multi-channel, I should say wide gamut, right? Workflows. But this is a cafe, so if you have other questions once we are through the main stuff, then just speak up. If you want to interrupt and ask questions during Dietmar's talk, please do so. You have the right and the privilege to ask annoying questions, especially because I don't have to answer them this time. Okay, so Dietmar, if you want to share your screen and get going, that would be fantastic.
Okay. So let's see if that works the way I think.
Yep.
So what we are doing today is we will speak a little bit about the three main ColorLogic products in order to create a packaging design that I will show you shortly, which is a CMYK design with some spot colors. And the spot colors and the CMYK parts as well should be converted to a 7-color, and I have chosen an indigo 7-color device there with some measurement data as well. And I would like to show you how you are using our tools to start from scratch, meaning how to create a test chart. Measuring is obvious, we don't show the measuring, that's clear, but then we have measurement data, we optimize the measurement data, we'll do that with ColorEnd. And after that, we switch over to Copra, which is the profiling application to create the 7-color profile, in this case, with CMYK, orange, green, and violet. And after that, we're using that profile in Zebra's color server to convert that PDF document and to convert the spot colors. So the basic image that I have here, or the design that we have here, that's my Brockes in South CAD package. I hope everybody can see that. So it is a PDF X4 document, which has an ISO-coded output intent, and it has some spot colors in there. So the spot colors, we can see the Pantone Reflex Blue and the Pantone Red here, which interacts a little bit with the CMYK underneath here. And we want to convert those spot colors, which are interacting in a way that it is that the overprints with the CMYK are faithfully reproduced.
Dietmar, maybe it's just me, but I'm still seeing your slide.
Okay. Okay. So let's see.
Maybe you shared PowerPoint instead of your screen. I think.
Okay.
Zoom allows that.
Yeah,
so
that's probably the point. So that.
Yeah, much better.
Okay. Yeah. Okay. Then that's probably So that's my cat food package that I have here, which I'll show it again, which is the CMYK part, and it's an PDF X4 document with 3 spot colors, basically 2 real printing spot colors and the die cut line here that we have inside here. So it's not prepared according to the new specification in terms of the non-printing colors here, but very often it is used like that, to use a spot color for die cut, for example. And then we have spot colors like here, the Pantone and the Pantone Red color here and the blue color, which are interacting with the CMYK part. And as we are wanting to convert this to be printed on a 7-color indigo, those spot colors need to convert in such a way that they are that the overprints with the CMYK are faithfully reproduced. And how to do that, I will show you in the next slides or in the next presentation parts. So now I switch to ColorEnd, and I hope you'll see that as well now. Oh, that's okay? Okay, good. So first of all, before we are starting with the measurement data, I will load already some measurement data here. We would start by creating a test chart. And with our color end tool, you have options there, like here, the custom chart option here, where you select, for example, a 7 color. Oh, that's interesting. I think there is something happening with this tool here, interacting in a strange way. So that's funny. Okay. I'll do this. New.
It's a demo. This has to happen.
Yeah, but I'm not sure why is that happening. Let's see.
Because it's a demo.
You're right. Okay, so let's do it this way. So first, if we want to create a test chart, then you go to that custom chart tool. And then in our case, it's a 7 color device. So we select 7 color. The mode will be profiling mode. We have a few other modes here. For example, if you want to create a 6F wedge file, you can do that. Or if you're going to Flexo, you can do that. And there are a few others. Typically, if you have a lot of space, you can use the large number of patches, which is 3,300. Or if you're having not enough space on your press, you could use the small one for profiling. So a minimum of 900 patches would be good for a well-behaved printing process. Let's phrase it this way. And if you're not sure about the well-behavedness of your printing process, then it's better to use a larger chart. So in this case, 3,300 patches. I click Start. And then you would format the patch list that we would generate for your instrument. So herefore, you would use the Export Chart tool. And from the list of the supported instruments that we have from Barberry, Konica Minolta, Techcon, X-Rite, the typical suspects, let's say it this way, you could select the instrument and the chart dimensions that you want to have. You can change them if you want. And in this case here, if I'm doing that for an I1, I0, you can see we end up with 4 charts that would be created if I click the Start button. I will just do this here. And then I can decide to create either TIFF or PSD or PDF document. I like PDF. And I click Start here. And what I have now at the end would be my reference file, which looks like this with all the patch lists in the randomized version. And I would have as well a PDF document that I can go and get to my printer and print it out. And after having printed and measured that chart, we can measure here with this measure button here, and then we can select your instrument to measure. You would have your measurement data. So the measurement data may look like this. So this is from a different test chart, but similar in size. So we have 3,100 patches here. We have a CYK part here, some oranges, some greens and violets. And in color end, you have those nice functionalities to really see how the original, let's say CYK, is extended with the additional orange here in that region, or the green in that region, and violet. And mostly we are doing this because we want to print more spot colors on the devices. And that's as well here the reason to adding the 7 colors. So that's our color space. Typically, we would like to look as well if there are any odd things that we can see right away, and we can see something here. The magenta curves is not that really smooth. We might see some other issues here as well with the black here. Let's put the orange, green, violet curves as well inside. Here, there's a little bit of redundancies and tears in the black. We see some nasty curves here in the magenta. It's not really bad, but at least so bad that I would do some adjustments. Adjustments means that we would optimize the measurement data, and we have some tools for that in the editing space here. Typically, you would make a redundancy correction. Redundancies are multiple patches which should have the same values. Let's say there's a 50% black multiple times in that chart, and you want to have the same LRB values inside there. A correction means we would fix some really bad things that happens. For example, if you should have measured the cyan, but it's measured as magenta because you've mixed the patch or something like this, the correction would figure this out and would correct that. And the smoothing would finally make a smoother kind of curves. This is all combined in the automatic feature here, and I will just apply that. And we will see how that comes out. And we can see this as well in the curves later on. So once that has been applied, we see our new curved results here. So that looks much nicer. If I look here into the magenta, you can always switch back to the original magenta, and you see, well, there has been some optimizations done to the measurement data to make it more react smoothly, and which at the end will give a better profile. So once that is done, we may use right click here, save as, or we use file save as, and with that we can save it into different kind of formats. Typically we take a CGATS file, either XML or text file. There are other formats like CXF, even Photoshop palettes and the strange other files are available there as well. So we just use the normal text file here. One little thing I would like to show you here, because for multicolor workflows, it is quite helpful to be able to exchange spot colors or exchange a color channel within your multicolor data. For example, here I've just loaded a Pantone Reflex Blue gradation curve. And if I want to use, instead of the violet that I have in my 7 color indigo, I want to use the Pantone Reflex Blue now, because I can change the color on my press, and the next time the client probably wants to print with that Pantone Reflex Blue. In order to facilitate and create a profile without having to print a new test chart again, we have this little tool called Edit Primaries here, where, for example, you could select from an existing other measurement data, like from the Reflex Blue here, the measurement data, click Start, and then all the overprints in that test chart will be recalculated. And what we see here is now that all these sections here where we have the CMYK, overprinting orange, overprinting greens, and the violet has been optimized, and we can use this data for profiling. So we're coming from this, where we had a lot of violet in here, and after editing, we see the blue is now using here, which means we can create a new profile, which now is not CMYK orange, green, violet, but orange, green, Pantone Reflex Blue. So that's a nice functionality, very helpful for packaging people. So, okay, so the next step is we have our measurement data.
Before you go on, you loaded data for Reflex Blue.
Yeah.
That was spectral data?
This is spectral data, yes, indeed.
Does it need to be spectral data?
It is definitely, it does not need to be, let's phrase it this way, but it's definitely suggested, because if you have spectral data, then you can calculate the overprints much more faithfully than if you have LID data. So spectral data is definitely preferred in both color sets. So the first one should be spectral and the second one as well.
Yeah, that was one question. The other is from me. So you can change the primary. Would there be a big quality difference in the profile if I would still print the test chart with Reflex Blue and measure that instead of changing the primary here, or would it be more or less the same, do you think?
There will be quality difference. So it is a prediction that we are doing here. So it's a spectral overprint prediction here. And if you have the time and the possibilities to really print a test chart, then this is preferred, that's for sure.
Yeah.
But mostly you don't have that time, and your print should go out in the next minutes or something like that. And for those kind of things, this is a very nice and helpful functionality. Right?
Okay. Thank you.
Okay, so the next tool I would use would be Copra to create the printer profile. For that, I switch to Copra. And let's see if we see funky things happening here too. No, that seems to be okay. I use the optimized data from the file we've just loaded. And here we get, it seems to work quite well. So all we need for creating a multicolor profile is a measurement data, preferable spectral as well, a setting, and then we could go to next and create the profile. That's it. But obviously it's not that easy. Mostly we want to customize our settings, and that's where this little customize button comes into the game. And here we would select a few settings to create the profile. And for those people on the list here who are not that familiar with Copra, there are a few very specific settings in there which differentiate it a little bit from other profilers out there. The first you will recognize is that the perceptual rendering intent can be optimized or customized to your specific needs, which means we have 4 different rendering or out of Gamut methods that we have in here that we can use. One might be very familiar to you. For those people that who know Photoshop, they know relative plus black point compensation. That's basically that setting. So we're having a perceptual rendering option here, which is similar to black point compensation, and a few others. A few others means we have one, which the standard compression, which is reacting more relative to the paper, so relative colorimetric to the paper, and this one is reacting more absolute colorimetrically to the paper. And this might be very helpful for the situation if you're printing on different devices, on different papers, but your perspective or the goal of your print would be to get to the same color appearance, regardless on which kind of process and printing and paper you're going to print. So it should look as close as possible to each other. And for this kind of purpose, the absolute compression is a very good, helpful method. If you're just printing to one printer and that's your goal, and you don't compare different printers, different renderings to different printers, then the standard compression is a good starting point. So in this example here, I just use standard compression. And there are other options like that. If you want to increase the saturation, you have options here. Or if the gray balance should be a little bit cooler or warmer, you have options as well to tweak that into your perceptual rendering intent. And indeed, what it says here, it is only doing this in the perceptual rendering. So all the other rendering options inside the profile, relative, absolute colorimetric rendering, will not be affected or will not be changed from this perceptual rendering. The saturation, by the way, will be using the same settings as well. This section here is not of that importance now for us. Let's say it this way. You shouldn't use the measurement correction if you've done that already in color end. So that would do it double. So, and we want to avoid that. So, but just to mention that. The color generation, that's more typical to what you're used to in all kind of profilers. There are black generation options, a GCR, like where you can define, okay, I want to have less GCR or a lot of GCR, and the curves will be adjusted. The black start is a very typical thing from a starting point of 0 here or to a later black start, and the curves will be accordingly changed, black width as well. Typically the question is, what does it do to my profile? Is it a good choice? And therefore this little Gamut view is quite helpful, and the Gamut volume that we display here. So let's see if I reduce the black width, if that does me any good. No, it doesn't. It reduces the Gamut volume that I have. I had 57,000 at the beginning, and now it's 56,000, 65,000. So we'll see that we have a bigger Gamut if we use a larger black width. The same here, if I start with a very little amount of black, we can see, okay, not that much of a change. Let's say if I have a larger one, it's a little bit better, but not really such a big thing. So we could use something in between as you like, let's say. So there's not such a big difference here. And I'm sure if I use a black start, I have a much bigger Gamut volume. So the typical ideas that people have a late black start, and they probably don't want to have that much black in the high saturated colors, will reduce the gamut. And that's very nicely visualized here with the gamut option. Therefore, using a high black width, a large GCR amount, and a early start black point is very mostly favorable in many cases. So that's just wanted to point that out. The other thing that is important in a printer profile is the black point. And here we have some options here which are different to other profilers around. We have two tag areas. We have one tag area for the overall tag. In this example here, I just used 350%, and the black tag. And this can be different. So it could be that, for example, in some digital presses, this very strange setting, using a very high amount for the black point, just using 100% black and a little bit of CMY, gives us a nicer black point in terms of density than if I would use a lot of black. And this happens very often with some toner instruments, toner printers like iGen and other printers. So you have options here to differentiate a black tag from an overall tag. Why we have that? If you think on 100% black, then, well, what do you do with a red? For red, you need at least 200%. And therefore, something like the option to be able to use something like this for the overall tag will be much more useful, let's say, for the overall profile. In our case here, the question is, which black point do we want to have? And do we have such a device here that I was speaking about? And therefore, the black calculation method auto is a very good starting point. You typically start with a 400%, and then Copra will calculate from the measurement data what it suggests as the best black point. And it would say 385% of tag. And now you would ask your printer, can I print 385%? And he would probably say, a little bit too high, perhaps use 350, 330 or something like that. And then you can go from there and reduce it to something more usable, let's say. But what we can see here, the L star value gets higher. So we lose a little bit of contrast here. And we can see that's 8.2, and we came from 6.6, for example. Yeah, so we are losing a little bit of contrast. And therefore, the black point is a very important feature in a printer profile. And this functionality here to show the LRB value and the tag value that we would calculate is very helpful. So something for the geeks, but very, very important anyway. So let's do something here for an Indigo. Mostly we don't have that problem, that big problem to using a tag of 330%. So we could use as well 350, for example.
Are these values related to 4 process colors or to the 7 process colors?
To the 4 process colors.
Okay.
You could as well, if you want the other process colors to be involved, you could switch to typically, so what we do typically is that we use the 4 primary colors for the calculation of the black point. Mostly those additional colors do not help that much for the black point. Now, so we can see that very easily if I'm switching to balance CMY, and let's assume we will add a little bit more of the violet to the black point, and we could see, it's getting worse. Now, so our L star value is getting higher, and we are adding a 5th color in our gray balance. Not a good choice at the end. In some printing processes, it might help, but in this case, it doesn't. You know, so we don't gain anything by adding more colors to the gray balance. And typically, you want the gray balance as smooth as possible and using just the CMYK part, which we do with the automatic. By balance CMY, you can change as well parts of it here, if you like. And with custom, you have as well you have all possibilities to change and even destroy your black point if you like. So you can put in any values here. And there's as well one which is the darkest black point that's possible. here in this example, typically we want an LAB with AB00, which is a neutral black point. In this example, if I use the darkest black point, I get to a very dark L star value, but 1.6 in A, meaning it's getting reddish, more reddish, at the end. So it's getting darker, yes, but not neutral anymore. You have options here to choose that. In some certain circumstances, this might be helpful. In most circumstances, it isn't. And therefore, using something like balance is a better option, and auto is a better option for starting. So 7.6, nearly 0.0 for the black point. So this is a very neutral and very nice black point. We have a good density here at the end, and we are now ready to create the profile. So at the end, we would create a profile. Oh, I forgot one thing, very important here. As we are creating a multicolor profile, the multicolor mode is important as well. We have a few options here. Those options are, let's face it this way, typically we start with a smooth separation, meaning the transition between the primary CMYKs with the orange, green, violet is very smooth. And if we use a strong option here, then it means we use more of the extending gamut colors, the orange, green, violet, so to pop out the colors more, and less of the CMY, which typically ends up with not so smooth curves. Let's phrase it this way. Therefore, we have those two options here to select from. And if I'm creating a new profile, I typically tend to create profiles with both options, so creating two profiles here, and then looking at the profile report and deciding from which I would select, which looks smoother and gives me nicer rendering of colors and so on. And there are a few other options here which are a little bit special, so we just leave them away. If there's a little bit time at the end, we perhaps can go to those if there's interest. But I think those two are the most important one, the strong and the smooth.
If you do strong, will it give you also a wider gamut in the end?
Not really, no. The gamut itself is independent from the separation in this part. It is more the inner parts of the profile. How much do we use the orange, green, violet within the gamut? The gamut size itself will not be affected from that, will not be changed from that. Okay. This mode, for example, here, the sparse inks is something like a safe ink option. Let's say for multicolor, we could use that for this. Okay, so once the profile has been created, so typically you go here and save the profile. There are a few other things which are quite helpful here on that page. First of all, the profile report. I always recommend to create such a report because it gives us some indications about the smoothness and then all this. And the save preview profile is quite helpful because once you're in the multicolor world and you have to deal with traditional tools like Photoshop, Acrobat, InDesign, and so on, you end up with some disappointments, let's face it this way, because in Photoshop, a multicolor profile will not show up correctly. So the colors will not show up correctly. And therefore, the preview profile is quite helpful because it's an RGB profile that will simulate how your multicolor will finally look like. So you could use that then for the soft proofing inside Photoshop. Or one very bad thing, and we'll probably can work around this now for the demo in Zebra. If we are converting a file, a PDF document with a 7-color output intent, typically Acrobat would crash because it can't handle the multicolor output profile, this kind of thing. So you have to do a lot of workarounds for, let's say, the typical tools that you have in your production. And yeah, that's one of those things you should be aware of when you work with multicolor. So most tools are not ready for multicolor, let's say it this way, and you have to use some workarounds to work with that. So the profile is created. So we have created that profile already. So we don't have to look for the the process to create a profile. That's not very interesting. And once the profile is there, let's assume we have created that profile and we have a report from that profile. And I would like to open that report just to give you an idea what we can see in that report and why it's so helpful. First of all, we see here in the profile statistics a lot of numbers. The most important part here is the precision. So how good is that multicolor profile? This is the delta E average 0.1 and 0.8 in max delta E. So that's very, very nice for a printer profile. The black point, that's the one that we've put inside the profile, the 350%, and we see the distribution of those colors for the black point. We see the LRB values. So that's basically what Copra has shown to us. So it gives us a good feeling that the profile is doing exactly what we wanted. So that's nice. The next thing is that we can see a Gamut view here with the extending color, orange, green, and violet. We see how the gray balance curves are looking like. So we are using a lot of black and less CMY. So that's nice. And we see as well a smooth visualization of, I will make that a little smaller here, from an image from Adobe RGB converted to the 7-color profile and converted back to LRD because Photoshop, now in this example, Acrobat can't show multicolor correctly. Therefore, we have to visualize that in converting to LRD. So you can see this. And we have some curves that we see and some channels here in the multicolor. Then we have an image here, this source image, Adobe RGB, converted to multicolor, so we can see how that image looks like, and we can see if there's some ugly things happening here, and it looks very smooth, very nice. So we are sure after looking into the report that our profile will do a good job. So that's Copra. Any questions first here on Copra? I don't want to spend so much time on the other things that will take us hours and hours. Just the printer profiling at this stage, and then we go over to the next. Any questions?
Could you briefly repeat how you avoid that the Acrobat is crashing?
Yeah, I will come to that. Yeah. So the point is if you're putting a multicolor profile into the PDF as an output intent, that's already enough to crash.
Yeah, I know that, but how to avoid that?
Yeah, just don't embed the output profile.
Okay.
So that's basically the trick that you can do there. Or use another tool that is able to display it correctly. So a tool like Colors PDF Toolbox is able to show you an output intent, multicolor output intent. So that could be a solution. Let's say it this way.
There were some other questions, Dietmar. I'm not even sure I understand all of them completely, but I can read them anyway. So you talked about preview profile, and you said this can be loaded into Photoshop then, correct?
Yes, right.
And the question was, do you load that with the abstract profile tool or in some other way?
So the profiles will always be saved into the system of your operating system. So the profiles are already there. So you don't have to do any tricks with that. Just perhaps I should show that to you. So that's maybe easier. So in case we don't have a preview profile, we can always create one after it. I'm just looking to the profile manager here. Output profiles, and we want to look into our 7-color profiles and something with an indigo in the name so that we minimize the amount of profiles here. So let's say I want to create a preview profile from this multicolor profile. That's the one that I've created, let's say. I created it before, but let's assume I have just created that profile. You can simply right-click and save a preview profile here from that profile, and now it's available.
Yeah.
And what we can do here in Photoshop, just to show that to you,
a very modern Photoshop version.
Yes, yes. The reason for that is it starts 20 times faster than the recent versions of Photoshop. And the color management works. In the newest Photoshop version, it doesn't work correctly. So be aware of that. If you work in Photoshop, newest versions of Photoshop are not really nice in terms of color management. Use better older CS6. Funny, but true. So this is one of our sample images that comes with Copra. So in Copra, for those who want to know, there is open edit targets folder, and there you find this little image here. It's an RGB image. I want to assign a profile to it. Let's take Adobe RGB, and let's see what happens if I use my multicolor profile. Convert to profile. In the advanced, so typically Photoshop would show this in the easy way, but here in the easy way you can't select the multicolor profile. You need to go to advanced, multi-channel, and then you select from the large list of multicolor profiles. Hopefully I find the one I want to use. That's the one. So that's the multicolor profile. So rendering intents can be selected. I choose perceptual. At this point, everything is fine in Photoshop. But as soon as you print the OK button, everything is crap. And that's because Photoshop is using his strange old multi-channel mode, which is there since CS1, I think. And it's not ICC aware, so everything that we see here is basically wrong. The channels are right, so the separation to the multicolor profile is all fine, but the preview is wrong. You know? And to have an idea of how that preview really looks like with your multicolor profile, you would go on the proof setup, custom. And here, as we can't select a multicolor profile here, but we can select our preview profile here. So here, my 7-color preview profile. So it's basically the same name than the printer profile, and the preview is added here in the naming. And this is an RGB profile. And with that, you could play as if you would have selected your multicolor profile, even with paper simulation. You can see this is a very bluish paper that we had here in this example here. And we would definitely see how the colors are looking like with our multicolor profile. And we could do some tweaking here in the RGB until we are visually pleased, and then we can convert that image to the multicolor. Even in Photoshop, the conversion will be fine, but just the preview would be wrong. And therefore, this little preview profile is very, very helpful, you know, because it really gives us some indication of how the colors look like. Okay, so that's one of those workarounds that you have to live with in the welcome to the multicolor world, I always say. Okay, so now the next step to create really a workflow, we would use a device link, because with a device link, we can do so many nice things like keeping grays and CMYKs pure and keeping primaries pure and so on. So we could create all this in Copra, but even nicer, we can do this on the fly directly with our color server. And this is where I would like to switch to now. Perhaps if there are some questions on Copra, feel free to ask them now.
There is one question about support for Miro instruments.
This will come in April already, as my other colleagues have told me. So,
but we are April.
Miro, Konica Minolta Miro is coming very soon, indeed.
Okay, and there is another one from Axel, but I suggest we first look at Zebra, Axel, and then you just speak up and ask your question, because I'm not really sure I can translate it, or even I'm not even sure I understand correctly. So let's look at Zebra first.
Okay. So with Zebra, for those people who are using Zebra already, there is a new update 7.08, which has been released just today. For other people who are not aware of Zebra, just a short overview here. This is already a setup system with a lot of queues here. I'm doing a lot of testing and everything here, so it's quite filled up. But just to give you an idea what we see here, typically, these are the queue sections. So all the queues that we have, or that I have here on my system, are available here. The jobs that are going to be processed, there's none yet, will be appearing here. And the process jobs, the list of all those jobs, can be seen here, including, for example, ink saving amounts can be displayed here. Typically, I like to use the sorting functionalities here. For example, if I sort it to the ID, then the newest version of the converted files will always appear here on top. So that's quite helpful. If there are some errors in the file, they will be marked red, and warnings will be marked yellow. So let's see if we have some here, for example. Warning is nothing to worry about. There is something in the file that we should keep in mind, but it's not really very dangerous. If there's an error, like in this case here, where I wanted to convert a certain spot color, but that wasn't defined, then this is an error, and then the file will be put into an error folder, and it will be warned as a red file here. So just to give you some ideas how that works. So when you set up your workflow, you typically do this via the home button here. And via this button, you get to all the configuration settings and all the default settings that you can define inside Zebra. One thing we would need in our case first is the auto setup. And we will use this. And it's always recommended to start with the auto setup once you want to create a new configuration. How that works is we have 6 setup modes here, which are very typical for normal use cases. With Zebra, we are converting images and PDF documents. And the idea here is that we are working like with a PDFX document. And for example, if you have a PDFX document, you typically want to normalize first all the colors that are within that document. For example, if the output intent is an ISO-coated and there is an RGB image inside. So typically the normalization process in the PDF means this RGB will be converted to the output intent first, and from there it will be converted to the new output condition. So that's the most important setup, let's phrase it this way. And that's the one we want to use here as well. We want to convert from ISO-coated to our 7 color. And that's where this comes from. You can do as well only the normalization step. So if your document is already prepared for your printing condition, but there are RGB or CMYK objects deviating from the color space of your output intent, then you could just do the normalization step. There is another one to save on ink. Total area coverage reduction is as well very helpful. And 2 others as well, which are less used often. So the first 4 are perhaps the most used one, and typically the first one on top is the one we want to use in this example here.
So what is the reason to first convert RGB to the output intent, which is CMYK, so you lose a lot of gamut, and then convert it to the 7 colors?
Yeah, the reason is the way how the PDFX is designed. So typically, if you open up a PDFX document with a lot of color spaces, what Acrobat will do, it will render it to the output intent and then on screen. And not only Acrobat, everybody that really honors PDFX correctly would do this way. And that's the way how as well the transparency modes in the PDF are working correctly. If you're converting from an object directly to the target color space, you would use, perhaps have some issues with some transparencies and transparency objects in there. So you probably don't want to do that. But you're right. If you have some designs, let's say, which are quite simple designed, let's say an RGB images are in there and no overprinting objects, no transparencies and so on. And if you are converting them directly to the multicolor color space from RGB to multicolor, then this would be beneficial in terms of the Gamut usage. You're right. And that's this workflow here. So you have an option to do that, the direct color conversion to new output condition. this will not go via the normalization step, but just print or convert directly to the output condition. So you can do that as well, but it's not recommended in terms of the PDFX, let's say, specification or the definition.
What technology are you using for normalizing?
Could you repeat, please?
Which technology are you using for? What is the underlying PDF technology you're using?
Yeah,
are you using the PDF library from Adobe?
Let's phrase it this way. Everything that we do here in terms of the PDF handling is our own technology. If it comes to flattening, we are using the Colors engine, which in turn, which then uses the Adobe PDF
library. Okay.
But only for flattening. Only
for flattening. Okay.
The rest is ours.
Okay.
And that's very helpful that it's ours, because we can do a lot more with that technology. And we have done as well some enhancements to the flattening engine that will not work in Colors, but work with us here. We'll probably see that later. Okay, so what you would do here is in Zebra, we have the full version here. The full version means the Zebra XXL, which is able to use multicolor profiles as well and spot color conversion. And it uses as well the Smart Link technique, which is our naming for dynamic creation of device link profiles. And that's what we want to use here. We want to convert from iso-coated to our indigo profile. So let's see what we have. Just type in the name of a lot of profiles here, and then only the list of the profiles that you want to see are available here. Then you select one of the rendering intents, very similar to what we've seen in the Copra application. In this case, I use standard compression and the Smart Link method. So typically we deliver 4 settings here, and these are the settings that you can add yourself into the system if you want to have something else. In our example here, we have a digital printer, which is a rather toner device. So we use that. That's basically a Copra setting, a Copra device link setting that we are using here to create that device link on the fly. Next thing is that we want to create the queue. So we want this a little bit shorter for to 7C indigo. And the queue is now set up. So that's our queue. And now we want to do some editing of our queues, because the spot color settings are not yet enabled, and the flattening is not enabled, and this kind of thing. So, but the basic color management settings are all set up. Just double click, and then you're in that configuration. Under document and target, we see our iso-coated, our target color space. It will be embedded into the output file. And now, Stefan, the important button, disable that. Otherwise, Acrobat will crash. So that's the thing here. So by default, we would like to embed our multicolor profile. Yes, of course. And we typically do that, and the auto setup will do that already. But for multicolor, we have to be a little bit cautious. So the next thing is image vector. Under image vector, we have CMYK, RGB, gray, LAB settings. Typically, all will be converted to the document color space. Embedded profiles and rendering intents will be honored. So we don't have to take care about that. Typically, vectors will be converted with the same settings like your images, because if you think on a flattened file, you have maybe some vector elements and an image side by side, and you want to convert it so that it looks color-wise the same. So you typically don't have to change anything here. And the spot color, here we need to do something, because typically we are retaining the spot colors. We don't convert the spot colors. In our example, we want to convert the spot colors. And here, the nice parts of Zebra are available with the spot color libraries. The spot color libraries are not available in Zebra automatically, so you have to do something. Either you are a Pantone Live user, then you can log into your Pantone Live. like Pantone Alive here, then those colors will be available. Or you load your libraries inside Zebra in a different section. And that's mostly the big work to create the spot color libraries that you want to use. In my example here, I want to use the spot color gradients, and we'll see what those contains. So in this spot color library here, all my spot colors that I want to use are available. For example, those 2 spot colors that I wanted to use, they are in that library. The library settings are here, spot color libraries. We go there, just save that here. And here is my spot color library. There's my Pantone Reflex Blue. There is my Pantone Red and a few other colors as well. For example, a spot color library in Zebra does not only contain a full tone of that spot color, like this one. It has as well the possibility to load a gradient with all the spot colors from that spot color to white. And you can even print it on black. I don't have this data here available, but you can print on white and on black. And this kind of information will then be used from Zebra for the overprint calculation. Now, if you just have the spot color of a full tone, then Zebra would have to guess how a 50% looks like. If you have this data from a CXF data or whatever kind of data you have, that's even better. And then Zebra knows, okay, a 50% of that spot color should have this LRB value. So it will use that. And if we have the printed data on black, which are missing here, we could even calculate the opacity, which gives us an even better rendering if we need that spot color to be rendered with the underlying process colors. So that's how Zebra works. So we can define your spot color libraries, and this is an unlimited number of libraries that you can put in here. So just from testing, there's a lot of files and data that I have here, but typically you have your own library, let's say, that you're creating with. For example, here there is a library with a few spot colors that I have, and even some opacity data is available here from some of those data. That's really a good library, let's say. In my configuration, switching back, I use exactly this spot color gradients configuration. What should I do with spot colors that are not defined? Like, for example, our die cut. Our die cut was not defined here. So yeah, the question is, what should I do with a die cut? Let's remember how this looks like. So we have that die cut. We can choose to not convert the die cut, or just leave it in the file, or as I want to have something like a proof on my Indigo, I would suggest we convert the die cut to the Indigo in the easiest way, because the color is not important in this example. So what I would do is I use the alternate color space information from the PDF here to convert the undefined spot colors. And for the spot colors that I want to convert, I have a few options here to do that. And for printing, it is so there are two ways, let's say, of converting spot colors. One would be like for the proofing, where I want to have a very precise match, which might end up with 0.1% of printing values inside in the conversion. Whereas in production printing, that is definitely not wanted. And therefore, an option like this, use the least amount of channels possible, is preferred. What that means, I could show you here, if I click here and make a sample. Pantone color cool gray. See? So let's see if we have something here. Coated. Okay, let's see. Okay. So just to give you an example here, the Pantone Cool Gray, so that's a gray color. And typically, if we are converting that to our 7C Indigo, we see the 7 colors here. And the grayed out colors here are the colors that we would use to get to a delta E of 0. So closest match as possible. but we would use 0.2% magenta, a little bit of yellow and some black to get there. And in proofing, this 0.2% is no problem. In printing, this can be a problem. And switching to use the least amount of channels, you will see this is gone away, and we just use the yellow and the black. So the delta E is a little bit higher, 0.1, well, really nothing. But the printing will be more easy for the printer, let's say, to do that. In a digital press, even in a digital press, this can be quite helpful because they have as well some register issues. And the more colors you print, the less smooth and the less fine, thin line, for example, can print. And therefore you want to use the least amount of channels possible. So we could do that. The list here is an exception list that is that you can set up yourself here. So that's all fine. It's not needed to put that in. I just did this for demonstration purpose for you guys here, so that you see what's the difference between the calculation methods. Typically, it's enough to select a spot color library, the calculation method, and this one, and then you're fine. Perhaps you want to see gamut warning if the gamut is, if the spot color can only be rendered higher than 2.5 delta E 2000, and we typically don't have to go to those settings. We could, but we'll leave it aside now. So that's my spot color settings. The
exception list that you have there, Dietmar, could I use that to handle the cut lines as well?
Yes. Yeah. No, we could put die cut in here and say, okay, we don't want to convert that. Yeah. Or we could remove it from the file, just throw it out of the PDF, or even replace it with a different spot color. So there are options to do that. Yes. So maybe we just make it this way. I'll leave the die cut in without any conversion. The other thing we want to set up here is the flattening. I mentioned the flattening. For setting the flattening up, you would go here. There are a few presets here, which are quite familiar to people knowing the Colors PDF Toolbox or Acrobat Professional. So that's quite similar to those things. We have a few presets that you could use. For spot color rendering, the solve overprints is a good idea to select from. And I mentioned at the beginning, we have enhanced the flattening engine with this preserve overprint appearance functionality that we've added here, which is quite helpful, especially if you're working in multicolor and spot color conversion. If you're converting spot colors to process colors, you can end up with overprinting colors, which knocks out underlying colors at the end. And this nice level of functionality, which is enabled all the time with our flattening, will cope with those things and make this work. So this is all enabled. I would use this of overprint in this example here. Click OK.
So what's the advantage of doing the transparency flattening in Zebra versus doing it in the output rib?
The point when the point here is if you're converting a file and the resulting file is a PDF, and the PDF typically has a few properties, let's say overprint properties, and you're converting even for CMYK to CMYK. Those overprint properties can lead into some overprint issues, especially if there are transparencies and overprints in the file, which is nearly in all the files out there. And therefore, if you're doing color management and you want to retain a PDF at the end that you want to print, you very often don't have a chance to not apply flattening. So you need to do the flattening during the PDF conversion, and then later on you have a nice file that every rib will be able to print because it does not do the hard work anymore. So therefore it is important to do that in the Color Server application. When your goal is to have a PDF at the end, then you don't have a chance other than to flatten. It's not always necessary to flatten. I need to say that. It really depends on the flattening effects. Yeah? For example, if you have a simple drop shadow thing, there's no problem with that. You can leave those transparencies inside. But if you have transparency, one of those 16 funky transparency modes, like negative multiplying or dissolve, this kind of things, which can have very ugly effects if underlying colors are changing, then even your color appearance can flip around. From a green it gets red or something like this. The alternate technical is a very good sample for that. If you use that and do some simple color management things, you will see that colors will be funky afterwards without flattening. So you have to do that, basically. In our example here, with this sample that I had here, it's not even necessary. So we can avoid flattening. So, perhaps we can do that because it's getting faster to do that, because we have the overprint effects here as well in our not flattened file. This file is a simple file. It will work as well without having to flatten that document. But typically, I just wanted to mention that the flattening is important if there are transparencies in your document, and if they're complex transparencies especially, and you're converting spot colors, then flattening is mostly needed. In our example, it doesn't. So I'll have that here. So my options, I don't have to go to the options. Just to mention that there are options for sharpening, for the image quality, for people that work with PSD and TIFF files. We have options to retain layers in PSD files. So it's really a powerful color server that Zebra here offers, and it's very helpful for all those packaging guys. So once your configuration is set up, you're ready to go. You can switch back to the overview here. And how Zebra works is you simply select your queue, right-click, open folder, and then the folder structure that has been set up from the auto setup is available. And then you simply use your PDF documents that you want to convert. Now, throw this away, it seems. There we go. My cat food image. And just into the server, into the input folder. And now the file will be processed and converted. And here the input folder, that's the place where you place your PDF document. The converted document will be placed in the done folder. If there is an error, it will be placed in the error folder. And the output, that's the folder where the converted file will later on reside. So that's our converted file that we've just converted. And if we open that here in Acrobat, we see it didn't crash, so that's nice. If we switch back to our original color, we see we have a die cut. We have the Pantone Reflex Blue and the red color here, and we have cyan magenta, yellow and black. And the converted one uses cyan magenta, yellow, black. It has the die cut because we have set the die cut not to convert. That's the reason here. And we are using green, orange, and violet. And with the way how we calculated the device link in between, we are seeing that, for example, our cyan in this example is pure cyan, pure magenta, pure yellow, pure black. And for example, here, the Pantone Reflex Blue is using cyan, magenta, and violet. And this way, the document now doesn't have any Pantone colors, but it's now ready to be printed. Well, it's not really ready to be printed on the Indigo because we still have the die cut in here. So we should have probably done a different thing here. So we don't want that here. We delete this and simply save the configuration again. Go to the overview. And instead of what you could do is go again to that folder, throw in your file, or you simply select a file, repeat job, and then it will be put manually, so to say, or automatically in that folder, and it will be converted again through the configuration to the changes to the configuration we've done, and now it will be processed. By the way, during the processing here, double-clicking will open the job properties, and the job properties gives us some indication about the file itself. So document information, it's a PDFX4 document, so the PDFX information is this one. The processing information are done, and the spot color that we have converted are listed here, and it gives us some indication how good the rendering of that spot color is. The red is delta E 2000 of 1.4 and the reflex blue of 0.7. So very good and faithful reproduction of that spot color. And let's see, that's my second file. Typically we would add to the file name the queue name plus a running number, so the ID of the running number here. And if I now open that file in Acrobat, we are seeing the die cut is gone because we've converted the die cut, and it is converted to the 7-color space, and it's now ready to be printed on my Indigo process, printing process.
So is this still a PDFX file?
At this point, it is, yeah, probably it is. No, it's not. No, it's not. I can show you something because you wanted to know. Now it's your fault. What I will do is I embed the output profile.
Yeah, if you don't embed an output intent, it can't be in a PDFX file. So.
And now I embed the target profile.
Yeah, by the ISO standard does not allow to embed a 7-color profile into a PDFX4 file.
Exactly.
But there is PDFX4N, which would allow 7-color profiles, but they're not embedded, they're only referenced.
Yeah. Mm-hmm. So let's see what happens. I will open that in Acrobat.
Yeah, I know that for a long time.
Okay, good.
It's always a hit in my seminars to demo that.
Okay, so what I will do is I'll open it in the PDF toolbox. And what we will see is what Zebra has done. It has created a PDFX5N file from it and has embedded the multicolor profile in the right PDFXN structure. So this is a way how to see if that's working correctly. We could even click here, I think. Oh, yes. And it checks that it is a valid PDFX5N document. Unfortunately, PDFX5N is not supported from a lot of solutions out there. So that's definitely one of those missing things in the world of PDF, that X5N, which is very helpful, especially as there are so many new printing devices with multicolor out there. It would be so nice if a lot of more tools would be available that support PDFX5N. Zebra does it, and we can cope with that already. So that's how you would use Zebra here for the conversion of CMYK plus spot color to 7-color extended color gamut printing. And perhaps you've noticed that. I will just go here over this. A spot color that we render to the full tone here, this will as well use the same channels for the gradient. Yeah? So we are using cyan, magenta, and violet. And as well for our 50% or here 20% of this, we will use the same channels. That's very important to have a smooth gradient and not switching between channels and making the colors a little bit funky. That can happen if you do this not in that way. So we are doing the conversion here. For the red here, we only have the full tone. Yeah? Gradations here are calculated according to an overprinting and gradation module modulation that we are doing here, which is an estimation in this point. But the estimation mostly is a good starting point. But as I said at the beginning, if you provide more information about the spot color, then Zebra can take this into account and will render the gradation more faithfully. Any questions to Zebra or the conversion that we've done here? Don't be shy. Oh, that's good. So
no? Okay, so I have some Australian questions for you.
okay.
I promised I was going to play the Australian here. I will not do the accent. I'm not sure how easy this will be to answer, and perhaps other people have opinions here as well. But one of the questions was how popular expanded gamut printing really is, because it's new. And so the question was, I guess the question to you, Dietmar, could be: do you really see this used by many of your customers, or?
Yes, we see that. Definitely the majority of people are in the CMYK space. You know? So like online printers and most of the online printers in Germany, for example, they're using Zebra for their color management work. But there are more and more coming using multicolor, and even in Germany, there are a few clients using it. I'm saying even in Germany because Germany so far does not use, or there are not so many multicolor users out there in Germany. There are more in the UK and in Poland and in the US. And indeed, some of the big US clients that we have, some of them don't want to be mentioned, they are using Zebra, for example, for the multicolor conversion they're doing. Yeah? Multicolor is as well, we have to say that, it's not always 7 color, it could be 5 color, it could be 6 color, it could be as well a 3 color device using Pantone red, green, and blue, for example. That's as well multicolor. Multicolor is everything beside CMYK, and for whatever reasons, there are those applications. And if we are thinking on multicolor, there are as well those large format printers, and there are those ceramic printers and textile printers. And if you're in textile or in ceramic, you're automatically in multicolor, because those guys would nearly never use CMYK. They use brown, yellow, some pinkish color, some brownish colors, and some oranges and such colors. And in those areas, and as well in the textile area, CMYK is the exception. Let's say it this way.
But in many of those cases, I think it will also just be the DFE or the RIP that does the conversion from CMYK to the multicolor that the printer supports, right?
Yes, they could do that. And mostly the people that are using RIPs for the color management and for the driving of their printer, they have seen that using Zebra in front of the RIP to standardize and to optimize the color management, and especially the spot color rendering, is much more superior to what the RIPs are doing. So they use the RIPs just for the last part, meaning to the rasterizing to the printer, basically. So all the color management is done upfront in something like a Zebra, and the files that are in the output folder can then be transported or automatically sent to the input folder from the RIPs, and then the RIPs will do the number crunching and the rasterizing and the linearization and this kind of things that you could do there with disabled color management.
Yeah.
And that's where Zebra is used as well in the large format areas with a lot of RIPs driving the different printers. Now, if you think on RIPs like Visage or even Onyx or others that have, let's say, sometimes a little bit limitations in spot color rendering, or if you think on device links, in which RIP can you use a device link? It's not so common to do that. then you see the beauty of Zebra, because it could do all that upfront, and the PDF is then rendered finally to the printer. And there, Stefan Jegi mentioned that. Therefore, we need the flattening upfront sometimes for the color management part, and then the RIP would do the last part, let's say, for the printing.
Okay, there was a second question that all the files have to be repurposed or reseparated, and how do you do that? But I think you just shown that very nicely, so that question should be answered by what you did with Zebra. And then the third question from this Australian gentleman was, how do you handle multi-channel contract proofing? But I think that basically the example you've given here with the Indigo to create a proofing file is also an answer to this, I guess, and some of the explanation of what you can do different for conversions of spot colors for proof versus production print. I guess speak to that as well.
And yeah, there's one thing to be mentioning. There is in 2 or 3 weeks from now, there will be a Zebra 8 coming. And indeed, we have a new, if you remember my auto setup here, we have a new configuration setup mode, which is called proofing. And that answered exactly this question that this gentleman has, because in proofing, there's a little bit more to be done. For example, in proofing, you want to add a media wedge. And in Zebra, you can do that. So you can add a media wedge, or you could even create dynamically a media wedge that takes all the spot colors from your PDF into account and adds them into the media wedge. Yeah. So that's a very nice functionality that we are adding here. And we've done that because, of course, we can do proofing. That's not a big deal here. And we didn't do proofing in the past because we thought, okay, there are so many RIPs out there that deal with proofing. But as soon as you're in the multicolor space or in the spot color arena, then it comes to limitations of those RIPs, even the high-end RIPs. If you think on the big names, let's say, there you either have to buy an additional very, very expensive module to do that, or you're very limited in a certain way. Yeah? So that the spot color rendering is quite, let's say, limited. And in Zebra, we have the first thing we have Cobra with that, which allows us to do iteration of multicolor. There's, I think, if the Drupa would have been this year, we would see more and more of those other RIP vendors being able to iterate a multicolor profile. We can do this already. So we thought, why not having that functionality here already inside Zebra? And that's one of the reasons why we added proofing. The other is the spot color rendering that we have, and which is very nice and very high quality, and others are missing that, let's say. And therefore we thought, okay, why not adding that inside Zebra? And that will be part of Zebra 8 going out soon.
Okay.
I have a question on proofing. Is that proofing on for offset, or is it proofing on an Indigo or on a large format?
Anything you want. So it all depends on the profiles, basically. Okay. So the workflow is the same as we've shown here. So you would convert your PDF document. You could even rasterize the document so that it's even easy to be used later on from the RIP or for soft proofing, for example. This can be any kind of device that you have at the end. You could even use your existing RIPs. So the rendering would be done in Zebra, and the PDF readily converted to your output device with your multicolor profiles can then be printed on your printer.
Okay.
I have a little question. When you say that your separations are made in Zebra, how do you have to configure your RIP software then? Just no linearization, just direct output?
Yeah, it really depends on the ribs. So, for example, if you're using a rib already for printing, then you would as well print a test chart on that rib for the profile process. In the same way you have printed that test chart would be how your rib should operate for the color managed version from Zebra. So that means I would, for example, if I have a rib, if I would have a rib here for printing on my printer, I would use the linearization functionality and ink limiting of the rib to make sure that everything is all right. Then I would switch off the color management linear setting. Maybe on some devices it's called a linear profile. On others they would have a checkbox to say color management, enable, disable. And that would be the setting you would use in your rib.
Yeah, because usually there's already issues with linearization in some rib software because they don't use a CTV or some more advanced features.
Yeah. If your rib, and that's another thing. I didn't mention that before. Here in Copra, we have a linearization option, and in that linearization option, we have options to use modern kind of linearizations, for example, this ISO 2654 or G7, or the combination of G7 and ISO 2654. Not many ribs do allow this today. And what we would do here would be to create a device link profile. For example, here, this is 1, 2, 3, 4, 5, 6. So this has 6 channels. So basically that's a 6 channel to 6 channel device link profile. I'm not aware of many ribs that can handle that. But in Zebra, you could do that. So you could create a queue here under gradations, and you would load that device link that we have, the linearization device links that you would have created, and would use the linearization curves. So basically, if you want to use a more modern linearization method and your rib can't do that, then it might be even better to disable the linearization within that rib, do the Copra linearization, apply it in Zebra, print the test chart via Zebra, via this linearization curves, with the linearization curves in your rib disabled, so linear curves, and then apply the color management on top of that, and later fill in, let's say, the profiles in Zebra as well. So in Zebra, you could do the color management from your document to the target, and the linearization would be part in the gradation tab here with your gradation curves. So all this can be combined in a big workflow, let's say, to compensate, let's say, for issues or limitations that you might have in your rib finally. And in some ribs...
Just a quick question. If you're going to disable the linearization and take over the color management in a third-party rib, a lot of them won't allow you to actually load a queue up without having some kind of default linearization in there. So could you have just a default linearization curve in there to start that you don't touch, and then do linearization in Copra and override it? Would that still work?
Yeah, there is an option here. When you save the linearization profile, there is as well this little checkbox, save curves as ISO, this number, XML format. And in some ribs support this. I'm not aware of so many ribs that support it. It's an XML kind of format, but I know that the ESCO color pilot, I think it's the name, or curve pilot or so, that supports it. And if there's a rib using that format, they could use the curves. Even the linearization that we are doing here could be used completely. So the G7 or the ISO 2654 curves that we've done there could be used there. So maybe that's part of an answer. For some of the ribs, it's probably not an answer because you're a little bit lost then. But as soon as they support these ISO standards, then you could use that.
I think it really depends at that point on the actual software that you're using for the rib. And in some cases, it's probably going to depend on the hardware that you're using as well, because there are devices where you can't switch off the color management in the device itself anyway. So then you have to do what the device gives you. But
yeah, finally, let's say if your RIP has what you mentioned, that you have a certain kind of setting, let's say, then your RIP is at the certain point a black box, and this black box should be, let's say, stabilized in a certain way in its behavior, and that's what you take for your profiling. And then you would print a test chart, measure, and create a profile from that black box, and that's the profile that you would use in your production. So it's a good way of working, let's say. No. So for example, when I'm using my Epson printers, my large format Epson printers, I just use the RGB driver. Obviously, this is a printer with 10 or 12 inks, but it's driven from an RGB driver. So basically the settings that I'm using there, that's my black box. I don't have control about how the colors are printing. I have to select something which gives me some nice rendering, let's call it this way. And on top of that, I would create a profile, and then the colors will look nice and clean and as they should do when I do that profile. But I need to print it and take it what it is, and that's my black box. And it's basically the same with the RIPs that perhaps don't have this switch off for color management settings. No.
Any other questions? Because we've taken quite a bit of time out of everyone's afternoon so far, but if there are any other questions, now would be a good time.
I have one more question. And this is from a commercial point of view. Very often we are facing, and I saw that there are some resellers also sitting in this call. We are facing very often competition with GMG. And I would like to understand how we can beat GMG. What are the unique features we have that GMG doesn't have? In some, especially in the color server and in the profiling.
Yeah. In terms of the profiling, something like this color end tool that we have is really unique. You don't find anything around that has a similar functionality. And the better your measurement data is, you're optimizing this measurement data, the better your profile will be. So that's the first thing.
Okay.
The second is Copra itself. If you think on, today I had already a webinar with a client who is currently testing GMG versus our solution. And after I explained him this additional possibilities in terms of the rendering intents that we have here, or the possibilities to tweak gray balance very easily, or adding saturation to a profile very easily, very fast, together with that nice report that we see already the results without having to dig into an Excel-like table that you are having to do in some other solutions. That can be a very big time saver already. The quality of profiles is not a big issue. Yeah. So from some competitors, you have heard perhaps ICC profiles are limited, but that's not true. Yeah? So you have the ICC profile world. You have the printer profiles there, but you have as well device link profiles. GMG, for example, are using device links. So you need to compare device links with device links. And in terms of device links, I think we have a few more options and few more possibilities than what GMG offers. So I wouldn't say that, let's phrase it this way. GMG tries to get the same quality that we get. They have a better, let's say, a larger organization. They have a good marketing, and they are much more bigger than we are, and have a good dealer network around the world. That's perhaps their biggest asset, let's say. But let's not forget, they are as well paper sellers. So their money comes from selling their proofing papers.
I know.
We sell only software. So we are focusing on software, and we try to get the best software out there. And I think we have an edge there. But as we are smaller, people looking at the bigger ones, being the big shots, let's say, and we have always to compete with them. That's for sure. But mostly, if people are giving it a try, testing it, using those profiles inside Zebra, we have definitely an advantage. Not only when it comes to exceptions, as well the multicolor modes. GMG just recently has multicolor support in their application. Don't forget that. So we have this since years. So we are probably years ahead in terms of multicolor separation. That's definitely a big advantage. And the color server as well is just now recently been updated to support multicolor. Open color is for proofing. It was for proofing in the past. And the possibilities to use the multicolor part was only part in their Photoshop plugins for images. And it was in packs, hybrid packs, but not in their color server. That's just recently added to their color server. And we have this since years. So I think that's definitely a thing to look at. And maybe that's perhaps something for another webinar. There has been a good comparison done from the FOGA multicolor forum. If you look into the results there, you will see quite well the strength and benefits that Zebra and all the solutions from ColorLogic have compared to other multicolor solutions out there. And I would say there are really two solutions standing out in the multicolor area, those from GMG and from us.
So Micha and others, if you haven't been looking at the chat window here as well, I think it's worthwhile opening that too and reading what Axel has been typing in there as well in terms of answers and comparison between GMG and ColorLogic. Given that he is he's been using both of the solutions, and he's an actual user. And as far as I know, he doesn't have shares in either of the two companies. There are some good points in there as well.
Yeah, but I think what he writes here, and I think that is what we experience with some customers. As he writes here, GMG is more user-friendly. I think for those people who are not very, let's say, have in-depth knowledge of color management, having a very user-friendly UI is very important to navigate through the software and get results. If you could look from a puristic, high-quality color management point of view, ColorLogic is the superior solution. But as he writes, you need to understand what you do. And that's where some customers are saying, hey, this is easy, walk through, good UI, interactive, intuitive, fine with me. Mm-hmm. So maybe this is an interesting kind of development point of view, or for a product point of view, to have ColorLogic thinking about making the UI more user-friendly to cover a wider audience.
Mm-hmm. Yeah, and in a certain way, it's very similar to what we experience sometimes with Pitstop and PDF Toolbox, for example. If you know what you're doing, then you can do a lot more with PDF Toolbox, yeah. But the UI is sometimes easier on the Pitstop side. It's very, very similar in that sense.
Mm. Yeah, I agree. So there are definitely a lot of settings that you can cover, and here in this webinar here, I tried to show you a lot of those things to give you an idea what you can do. I think if like with any software, if you have really interest in the software, you really need something like a training. And I think there are some basics in each of the software. If you understand those basics, then you can really start already very fast using the software. And if it then comes to more, then you need to go and understand the bells and whistles. But that's, I think, as well the same with every software. Mm-hmm. And Yeah, but I take that point to think about more user friendliness, let's say, yeah, let's see what we can do there.
Okay, what I would suggest at this point, unless someone has urgent questions still, is that we finish this one up. This was a fairly long one, but it's not a bad thing. It was interesting.
Thanks.
I would urge everyone, if they still have questions. I know there is one from you, I think, Leon, who was not answered yet. I would suggest that if you still have questions, just put them on the Four Pees Café group, and we'll see whether we can convince Dietmar to come back and maybe answer some more specific scenarios a little bit later. For now, Dietmar, thank you very much for the introduction into this extended gamut. I think, judging by the reactions from people, it was very interesting. So thank you very much for that.
Yeah, thank you.
Thank you. Thank you.
Thank you, everybody. Thank you, Dietmar. Thank you
for your time. Thanks. Have a good time.
Bye.
Thanks, everyone. Have a great day.
Bye.